How you doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world. And if you haven't, please go ahead and subscribe. If you want to support this channel, links down in the description. And make sure you check out my other channel where I do mountain bike and DIY stuff. I'm going to leave a link for y'all somewhere down in the description or a card. Make sure you check those out. Okay, today we're going to be talking about proportional relationships and graphs. Okay, so this is going to be very similar to constants rates of change that we talked about in the previous video. I'll leave a card right here. You can check that one out. And it's basically going to be the same thing, except now we're going to look, instead of tables only, we're also going to look at graphs, okay? And this is probably something that you have already seen before. If you remember the words rise over run, like when you're finding the slope or something like that, this is going to be very similar, if not directly related to that. Actually, later on, you're going to learn this with different words, but it's basically the same concept. Okay, so proportional relationships and graphs. The graph of a proportional relationship is a line that passes through the origin. An equation of the form y equals kx represents a proportional relationship where k is the constant of proportionality. Everything that we have already learned, okay? So basically, k is we found k by doing y divided by x. So this equation is the one that I showed you previously, that is a factorization of this equation, or broken down of the same equation, so you can come play it back and forth. Okay, the graph below shows the relationship between a number of peanut butter sandwiches and teaspoons of peanut butter used for the sandwiches. Now, a key word that they made over here is a proportional relationship is a line that passes through the origin. Does anybody know what the origin is? And if you know, please leave it down in the comments. I'd love to hear what you know about the origin. Now, if you don't know what the origin is, whenever we have a graph, we have different, let's look at tables, okay? First of all, a little bit of background on tables. We have tables and we have quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, now if we look at this graph right here, that graph is that section only, quadrant 1. Everything is positive in that graph. Okay, now with that being said, it says the origin. The origin of a graph is going to be the point 0, 0. Now we're going to be talking about points, coordinates, and coordinate planes and all that fun stuff, okay? The origin of a graph is going to be the point 0, 0, which is the very corner. So in this case, this graph, the origin is right here. Now they're saying a graph proportional relationship is a line that passes through the origin. Anytime you see a graph like this, and I'm jumping ahead because I want to give you the keywords, okay? Or the fastest thing to recognize a proportional relationship, okay? So what this means is that when you connect the dots and you make a line, that line is going to pass through the origin. It's going to be a straight line, not necessarily vertical. It says a straight line, like a really straight edge, okay? So if I connect these points, for instance, right there, it passes through the origin. And if you don't have any points somewhere in the graph, you can just go ahead and put them in there. And you can estimate what's going to happen, right? Because the points, they go on a straight path and is proportional. Now, if the line is straight, however, if it does not pass through the origin, let's say you have points right here, and you connect those points, that's going to be a straight line again, but it's not going to go through the origin. So therefore, it's not going to be proportional. If you're looking for a proportional relationship in a graph, it has to pass through the origin. So this right here is not good. That's the main thing about graphs, okay? Now, let's see what this says. It says the Y value represents the amount of peanut butter, and usually you're going to have them labeled. And then the X value represents the number of sandwiches. Okay? So it says that, and if you look at the graph, this is something that you're going to be paying attention as well too. If you look at the numbers, they don't go one by one. Sometimes they're going to be scaling them like, I don't know. So if you see right here, it kind of goes one by one, but they just don't number everything. This is 1, 3, 5, 7, 9, right? But if you look at the other graph, it's not going by ones, it's going by 3. So this is 3, 6, 9, 12, 15, 18, 21, 24. So it's going by 3. So you got to be paying attention to those graphs every time you make the 2 points, okay? Okay, let me put my mask on because people got here already. So, where we left off, it says right here, to make 6 sandwiches, this is how we're gonna connect them. So basically, we're gonna get a whatever color you want, and you're gonna pick one point, and you're gonna make a line like that. You're gonna connect like that. And that means to make 2 sandwiches, you need 6 spoons of peanut butter. And you can pick any point to do this, okay? You can pick any point to do this. So for instance, if you pick this point, you can say, well, to make 6 sandwiches, I need 18 spoons of peanut butter. It doesn't matter which point you pick, and you can also estimate what's gonna happen on another one. Like for instance, right here, if you pick this point right there, we did not have a number right here, but I did put it in there, and that's a 7. And we did not have a number right here on the Y value, but I did put it in there, and that was a 21. So you can expect to know what's going to happen, okay? So if we select this point, we're going to name it as a number pair, order pair, okay? An order pair is always represented in the X, comma, Y fashion. That means that you're always going to write the first number as the X, comma, second number Y. So in this case, it's going to be 2, comma, 6. And if we remember correctly, if we look at this value right there, to find K, all we have to do is write Y over X. In this case, it's going to be 6 over 2, which is going to be 3. They picked the pairs, the order pair 6, comma, 18. But in this case, if the Y is the 18, the X is the 6, whenever you divide 16 divided by 3, you also get 3. So it doesn't matter which point you pick, as long as it passes through the origin, it is proportional, and the relationship is going to be the same. So this is going to be K, okay? Now to write the linear equation or the relationship, the equation for the relationship, you're going to use the equation Y equals KX, and we're just going to replace the K value, which we just found right here. So this is the equation. Now, for numbers 1, it says, fill in the blank, write 2 equations for the given proportional relationship. They're already telling you that they are proportional, but you can also do the line test. Anytime you have a graph, make sure you do the line test. So all you gotta do is make a line, make sure it passes through the origin, and if it does, like in this case, then it is going to be proportional. If you make a line in this one, it also goes through the origin, and then it is going to be linear and proportional, okay? Now, in here, it says, what does the X value represent? So you're just going to look at the X-axis, Y-axis, X-axis, Y-axis. So in number 1, the X value represents the time worked, or the hours. The Y-axis represents the money. So we're going to pick any point to find K. K is the constant of proportionality. Any point. You can pick any point. It does not matter which one you pick. You might want to pick the easiest one to work on, but again, it doesn't matter. So I'm just going to go ahead and pick this one right there. And if I connect them, I get my 2 values. K equals Y over X. In this case, Y is 28 and X is 4. And when I do TiVo, when I divide top in, bottom out, 24 divided by 28 divided by 4 is 7. So we're going to be using the point, again, this is X, comma, Y. And we're going to do 4, comma, 28. You can pick any point you want. And then you're gonna set up your fraction. So it's gonna be 28 over 4, which we just did right here. So k equals to 7. And to write the equation, all you gotta do, this is the format, write down replacing the k value. So y equals 7x. That's it. That's all you have to do. Now for the other one, number 2, we're gonna pick another point as well. Now, always pay attention because they're not going one by one. This one is going apparently by 3s, right? This is going by 3s, so you gotta pay attention on that. And in this one, if you pay attention, they're going by 12s. Okay, so you gotta be paying attention to that. They're scaling them down because if they put it in one by one, it's not gonna fit on the table. So that's why they use scales like that. So the first point that actually has the two numbers given to you is gonna be this one right there, 24 and 12. So when you connect them, your x value, comma y value is gonna be 12, comma 24. So the x represents the number of students, is right there, the x-axis. The y represents the cost, the admission cost. So we're gonna use a point, I already picked it, 12, 24. Let's scroll up so you can see this. Now we're gonna divide. Y goes on top. Remember, this is the x, comma y. A good way again to remember that is the alphabet. X goes before y. Now, there's gonna be 24 divided by 12. 24 divided by 12 is just 2, and this is k. So the equation is y equals to x, and you're done. And you are done. So, that's really all there is to this. We're using the same equations as we used before. If you learned something today, make sure you give it a thumbs up. If you have any questions, leave them down in the comments below. If you know somebody that's struggling with this subject, make sure you share this material with them. Otherwise, that is it for this one, guys. Don't forget to subscribe to my other channel. That's it for today, guys, and I'll see you on the next one. Goodbye.